So you've watched the video about inverse trig functions, and basically, and so you are aware of cosine, which is also referred to as arc cosine. I'm going to use arc cosine because I think, like it was said in the video, the negative one is confusing. Remember, this is not cosine to the negative 1 power. This means inverse. Just like in pre-cal 1, that meant the inverse of f. It did not mean 1 over f, that means inverse of f. And I know that's confusing notation, so that's why I usually use arc cosine instead of that thing. Likewise, we have this, which I'm going to refer to as arc sine, and same thing for tangent. So what you should know at this point is that we use arc sine or arc cosine to undo cosine and sine. And just like you use square root to undo squares. So in this case, where we have just a straightforward cosine x equals 1/2, we're trying to solve this equation, which means we're trying to find an x, a number we can replace the x with that'll make the equation true. We're going to undo both sides of the equation by taking arc cosine on both sides. Now again, when it's a friendly angle, the way we would do this is we just use our knowledge of the unit circle. We're asking ourselves, what angle will give me 1/2 when I plug it in? And so you should immediately get this picture. Because we know in this case, the x value is 1/2. So both of these angles would give us a cosine value of 1/2. You might also think of these angles, but you wouldn't use them because those give us a cosine value of negative 1/2. Okay, so this is the picture that should conjure up. So we're trying to undo cosine. So the action we're actually going to do is we're going to do arc. We're going to do arc cosine of cosine x and arc cosine of 1/2. So of course arc cosine of cosine x is just x. Arc cosine of 1/2 would be, well, it could be pi over 3, or it could be, would that be 5 pi over 3? Or if I spin around the circle, so that would be 6 pi over 3, 7 pi over 3. Or if I go all around there, 8, 9, 10, 11 pi over 3. And of course I could just keep going on forever. Okay? So often what will happen when you're asked to solve an equation, they'll ask you to either solve the equation for all values, which in that case we're going to have to get tricky because we can't list all of them because there's an infinite number of them, because we can just keep spinning around the unit circle forever, producing more 1/2 values. So if we're looking for all values, then we do something like this. We let x equal pi over 3 plus, and what we say is any multiple of 2 pi added to this will give me another answer. So we go 2 pi over 3 plus 2 pi k, where k is integers. But we also have 5 pi over 3 plus 2 pi k. And you can see that pi over 3 plus, if we put in a 1 for k, will give us that one. If we put in a 1 for k here, it'll give us that one. If we plug a 2 in for k, it'll give me, that would be from here 1, 2 trips around. So this would be, if they ask you to find all solutions, you'd have to write it something like this. If they ask you to find just, and we will do this sometimes, they might say find all solutions within the range from 0 to 2 pi. In that case, you would just cut these off and just say, there's my answer right there. Okay? Okay, now what if it's a little bit more complicated? So this one has other stuff besides just the cosine. So in this case, I'm still, the normal things I use for solving equations still applies. So we're going to just begin undoing stuff. So I'll subtract 1 from both sides, and I get 2 cosine x is equal to 1. Divide both sides by 2, and I get cosine x is equal to 1/2. And notice we end up with that same thing we had before. So at this point, I take arc cosine of both sides, and I get x equals pi over 3, 5 pi over 3. And again, that would be my answer if I didn't, if they asked me for just the answers between 0 and 2 pi. If they asked me for all solutions, then I'd have to go further and do that over there. Okay? So that's basically what it's doing is what we're doing is when we're solving trig equations is we're using all the information we already know about solving equations, and then we're just adding this one new inverse function. Well, I guess 3 new or 4 new or 5 new, but we still have the ability to add the same thing to both sides, multiply the same thing to both sides, divide, take the square roots, square, all that kind of stuff. So let's look at another example. For example, let's say we have 4 sine squared x is equal to 2. Okay? And by the way, I don't know, I can't remember if we've shown this notation before. Yeah, I think we have. That means sine the whole thing squared. We usually put it here just so we don't have to put parentheses around it, because if you didn't put parentheses around it, this would be confusing, right? You'd think it means sine of x squared, right? It would be confusing. So these are not equal. These two are the same thing. Okay? So if we're going to solve this, first thing we do is divide both sides by 4. So we get sine squared x is equal to 2/4, which of course reduces to 1/2. And then, because there's a square here, we're going to square root both sides, and we get sine of x is equal to the square root of 1/2. Of course, that would be plus or minus, because anytime we square root both sides of an equation, we have to consider both the positive and the negative. And that would be sine x is equal to 1 over square root of 2, or negative 1 over the square root of 2. And again, so then at this point we're going to take the arc sine of both sides, but what we're really doing, because these are clearly friendly angle answers, is we're thinking about the unit circle, and we're saying what angle would produce 1 over rad 2 and negative 1 over rad 2. And of course that's all the multiples of 45, right? So for sine, for sine, these two would produce the positive, and these two would produce the negative. And again, let's say that they wanted to find all solutions between, or on the interval, sorry. On the interval 0 to 2 pi. So then my answer would be x equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Let me do one more example. Let's say we have tangent. Let's see. 3 tangent x minus 4 is equal to negative 7. Okay, so first thing we do is add 7 to both sides, and we get 3 tan x is equal to negative 3. Divide both sides by 3, and we get tangent of x is equal to negative 1. And now we take the arc tan of both sides. So we're looking for when x is equal to -1. So we spin around here. That would be when sine and cosine are the same. So that's the 45 options again. So that would be here. Nope, we said -1. So it would be here and here. So that would be 3 pi over 4 and 7 pi over 4. If we're looking for just between 0 and 2 pi, if we, let's say in this case, we want all solutions. Now with tangent, notice that the solutions, tangent repeats itself every pi instead of every 2 pi. So in this case, if I'm looking for all solutions, I don't really need to write more than one, because notice if I choose 3 pi over 4, if I add pi to that, it takes me back to the next answer. If I add pi again, it takes me back to, so anyway, I can hit every answer by just adding pi over and over again. So my answer here, if I'm looking for all solutions, would be 3 pi over 4 plus pi k, or k pi, or whatever. Where k is integers. So 3 pi over 4 would be right here. 3 pi over 4 plus 1 pi would take me around to there. 3 pi over 4 plus 2 pi would take me around to there. And also, notice k is integers, so I could put negative in there. So 3 pi over 4 plus k, plus negative k pi, would take me from here back to that guy, which would be negative pi over 4. So with this, I can get all my solutions. Okay?